to today's lesson. So we're going to be focusing on solving exponential equations, right? But before that, remember, we're going to map out what we're going to look at, and then at a later stage, we'll then look at some examples that have to do with everything that we're going to talk about today. So remember that firstly, to map out our concept of exponents, there's what we call the laws, which you've really been doing from the early grades and all of that. And then now we're going to introduce what we call rational exponents. And then we're going to have radicals, which are the same as surds. But for now, I'm mainly going to be looking at the concept of equations, right? And those equations will include some rational exponents there for us to look at. Now, the keywords for us, remember, is the prime base. I know that prime numbers is something you're familiar with, but now we're going to change our bases and write them as prime numbers, right? And then also there's what we call the reciprocal. Remember, a reciprocal will be more like you tipping and timesing a fraction. So if I have A over B, the reciprocal of this will therefore be B over A, right? So we're going to be talking about the concept of a reciprocal in this lesson. Now, when you talk about an exponential equation, this will be an equation in which the variable is the exponent, right? So if I have x squared, that has nothing to do with exponential equations or expression. It's just a term that has an exponent of 2. But as soon as the x is then the exponent itself, we then call it the exponential equation. So as you can see here, 2 to the exponent of x, that x of mine is the variable, and it becomes an equation because of the equal sign, because remember, equation is a relationship between two things, which we normally show using an equal sign. Now, when we are solving exponential equations, the very first thing, the same with expressions, the same with all the concepts of exponents, you are to make sure that all the bases are the same by doing what? You are rewriting them as prime bases, right? So the important thing here is to make sure that they are prime numbers. So for example, if I have something like, let's say maybe I have 4, right, squared. This is the same as 2 to the exponent of 4, agreed? Now, if I give you something like 64, I know that 64 is the same as 8 squared, but 8 is not a prime number. So I can just go straight to a prime number by saying this is just the same as 2 to the exponent of 6 there. That's what 64 is, right? So that's one of the things that I just mean when I mean make sure that you rewrite the bases as prime bases. If you leave it as 8 and then go there, they will be like that additional step that you will need to do, which is kind of a lot of work. But for you to understand this, you're practicing, start there until you are used to rewriting certain terms in exponential form. Now, let's look at the previous example that we were looking at, which is 2 to the exponent of x is equals to 16. This is the same as 2 to the exponent of x, which is the same, which is equal to rather 2 to the exponent of 4. What did I do? I just rewrote the 16 in the form of 2 to the exponent of 4 using the base that is a prime number, right? Now, that is the prime base as I've just told you now. And then the second thing that you need to make sure you do here will therefore be to use the laws of exponents to do what? To simplify both the sides of the equation to a single power with the same prime base. Now the goal here is to make sure that if I have a lot of bases, right, on one side multiplied together, added together and all of that, and on one side again multiplied, divided and all of that, the goal is to make sure that I have one power, meaning 2 to the exponent of it doesn't matter what is there, equal to 2 to the exponent of it doesn't matter what is there. But the important thing are the two 2's that I have as my basis. And that's the goal. That is what we are trying to do after converting them to be in exponential form. So this step says what? Simplify one side, simplify the other side, such that you have one power with the same base. Remember I said the word power does not necessarily mean exponent in this concept. It means the whole base with its own exponent. The whole thing, we call it a power. So please make sure you do understand that. Now, just an example for this, it will be 9 to the exponent of x minus 1. So to simplify this, I must change everything to be the base of 3, right? Or a prime number. So this is going to be 3 squared into x minus 1, and this is equals to 3 cubed into x, right? Then multiplied by 3 to the exponent of x plus 2. And then what do? This will then give me 3 to the exponent of 2x minus 2 equals to 3 to the exponent of 3x. Because the bases are the same, I will just add the exponents, plus x plus 2, right? And then the last step now will be, when those bases are the same, you can now equate the exponents, right? You can equate the exponents by doing what? By getting rid of the bases and just leaving the exponents as is. That's what equate means. So let's look at the previous example. Remember, it was 3 to the exponent of 2x minus 2 equal to 3 to the exponent of 4x plus 2. What this is, you're going to get rid of that base and that base there, meaning you will equate your exponent, right? Equals to 4x plus 2. So the law here is, when the bases are the same, definitely the exponents need to be the same. If you solve this using your normal algebra, it will be 2x minus 4x is equals to 2 plus 2, which is negative 2x equals to 4, and then I will have x is equals to negative 2 as my final answer there. And that's what you will therefore need to do there. So please remember, the main thing, make the bases the same. If the bases are the same, make sure that you simplify them such that you have one power. And then after that, lastly, you then equate your exponents, provided that those two powers you have on either side have the same base. If they don't have the same base, you don't do anything of that sort. I'm not dividing bases or anything like that. No, I'm just equating the exponents, because the law says if my bases are the same, consequently my exponents therefore need to be equal as well. Guys, for now, I know I've kind of shared a lot so far, but I want you to just stretch a bit so that when you come back to do a few questions that have to do with everything I've done thus far, you are refreshed and you'll be able to try them with me. Let's go to a quick ad break. I'll be back just now. Stay tuned. Hi guys, welcome back from the ad break. So I hope you are now a bit refreshed and you have your pen and paper. If you did not have it, you are now ready to work with me, because I promise you, if you are not following what I'm going to do here, you are really going to be lost, and I would really hate it for you to be lost. So make sure that you have your pen and paper, or your pencil rather, so that you can erase wherever you're not understanding, and some highlighters, by the way, so that you can highlight some important things that I am busy doing here, and other colored pens so you can make a few notes there, because really that's how I do my practicing of maths. I like it when it's colorful, so maybe it can work for you as well. So remember, so far we've looked at what? The exponential equations, right? Mainly the three steps that we always need to follow. Make the bases the same, make sure that each side has one power, equate the exponents, and then solve, right? Solving is not really a step, it's just algebra. It's you doing what you are supposed to do. Now let's look at a few questions that exactly ask this, right? Now, because we're dealing with equations, the question is not going to be simplified, but it is going to be solve for x, right? So we're going to solve, and then maybe at the end try to show that our answer is actually correct. So let's look at a few questions together. Now, the very first question is 3 to the exponent of 1 minus 2x equal to 27, right? then the following one will be a fraction, the other one will be a decimal. I've just tried to play around with the example so that you can just see the variety of how to then work this out. So let's look at the first one. This is straightforward, right? What do? You make this to have a base 3, right? Why base 3? Because the left-hand side cannot be changed to any other base. That's why I'm just saying already make it base 3. So this will be 3 to the exponent of 1 minus 2x. I'm just going to rewrite it. Equals to, remember 27 is the same as 3 to the exponent of 3, right? And then because the bases are the same and you have one power on each side, your step here will be to equate the exponents, right? Equate the exponents. And then to do that, it will be 1 minus 2x equals to 3. Then your algebra comes into life here, which will be minus 2x equals to 2, and then x will be equals to negative 1, right? Just for people like myself who are still trying to understand maths, where does the 2 come from? It's going to be minus 2x equal to 3 minus 1, right? So that's where the 2 comes from, just so that I don't lose you there. Now, the second example is the one with a fraction. You don't need to be scared of anything here, right? Remember, one of the definitions that we've done when we looked at the introduction of all these exponents was, if I have 2 to the exponent of negative n, this is the same as 1 over 2 to the exponent of positive n, right? So meaning, this is a reversible equation, if we may call it like that. So it means I can then rewrite 1 over 2 to the exponent of n as 2 to the exponent of negative n. Why am I bringing this to your attention? Because we then need to make this part here to have a base of 2, right? We need to make this to have a base of 2. It means it will be 2 to the exponent of minus 1, because my n in this concept will be 1. And then all of this to the exponent of x plus 1 equal to 2 to the exponent of 2x minus 4. Now, before I can allow any other step, I must remove my brackets. So making this 2 to the exponent of negative x minus 1 equal to 2 to the exponent of 2x minus 4, right? I have one power, base is the same, then what do? The step will be to equate the exponents. Equate the exponents. So to do that, it will then be minus x minus 1 equal to 2x minus 4, right? And then from here, you will then simplify this, which will give me negative x minus 2x equal to negative 4 plus 1. And this will be negative 3x equal to negative 3, which is the same as x is equals to positive 1. Now, just before we do the last question, right? I love that when I'm always doing my maths, I like coming out of the exam knowing exactly that I got this amount of marks, or rather I have an idea of how many marks I got. And how do I do that? I do that by checking my answers, right? When you're checking your answers, remember that I said an equation is a relationship of two things, right? Or between two things. So a relationship that has an equal sign means that what you get on the left-hand side must always be equal to what you get on the right-hand side. That's what the checking is. So if I substitute what I claim my value of x is into where x is, it must give me something on the left, and what will be on the right must be the same as that something that's on the left-hand side. So if I get 5 on the left, I must get 5 on the right. I get 0 on the left, I must get 0 on the right. Then I will know that my answer is correct. If I don't get that, then I can always go back and recheck where I made my mistakes. Because remember, we are human beings. Some mistakes that we make will have to do with multiplying a negative with a positive. You forget that it must give you maybe a negative and all of those things. So make sure that you always just try to check your answers. Even if you work it out on the calculator, you don't need to rewrite it. No, just press the calculator and check that it gives you left-hand side equal to right-hand side. If it does not, just go back and recheck your steps. That's how you check your answers. You don't then write the whole exam and then want to recheck and scratch out and write incorrect answers. No, you check by taking the answer you got and substituting it. Let me show you what I mean. So this is, if I check this, is going to be 3 to the exponent of 1 minus 2 into negative 1, and this will be equals to 3 to the exponent of 1 plus 2, right? It will be 1 plus 2, which is equals to 3 to the exponent of 3, right? And that's 27. What is on the right-hand side? On the right-hand side, this is 27. Therefore, you can see that my left-hand side is equals to my right-hand side, right? Therefore, my answer is correct. I can move on to the next one. Let's look at this one. We got the answer as 1. And by the way, the other thing I need to mention when you are checking is you don't check on the one that you've simplified already, because at times after simplifying, it kind of changes the question. You substitute on the original one that I gave you. So I'm substituting on the original that I gave you. Now let's look at the left-hand side. I'm just going to do it up here because that's where I have my space. This will be 1 over 2 to the exponent of, my x is 1, right? So it's 1 plus 1, which is equals to, the exponent will be 2 there. Therefore, this will make this to be equal to 1 over 2 all squared, which I know you know it will be 1 over 4, right? That's the left-hand side. Let's look at the right-hand side. It must give us 1 over 4. If it does not, there's something wrong. So this is 2 to the exponent of 2 into 1 minus 4, which is equals to 2 to the exponent of negative 2, because 2 times 1 is 2, minus the 4, it will be minus 2. And this will be equals to 1 over 4. Look at that. Therefore, you can see left-hand side is equals to right-hand side. Now, guys, I know that I said this is me checking my answers, right? I'm not saying you need to do this in the exam, right? For the person who's going to mark your exam. No. You are doing this for yourself so that you know that your teacher, when they mark, you're going to get these marks, right? You know these people that come out of the exam room and they say, hey, I got 50 out of 75. And they are speculating. It's because most of them do something like this at the end of the exam, so that they are sure that these ones I'm very sure. But the other 25, hey, I tried my best, but we'll see what the teacher says when they mark. So that's how you then come out of the exam happy and say, I got this amount of marks. So please do make sure you do this. But you don't need to write it in the answer script. If you do, then indicate with your pen, check, and then work it out. You don't just work out one long thing and then you also check under there, because what that tells the person who's marking your paper is your final answer is the one of you checking, not the one where you say x is equals to. You see, then you are going to lose some marks for the final answer there. But if you are checking, indicate, check, and then check your answer. You can write it in your script, it's not a problem, but you must be specific that you are checking. If you don't write it, then just do it on the side as I initially said. Now let's look at one more example. Now with this one, it's a decimal, right? Remember when we taught you in your early stages of learning mathematics how to convert decimal fractions to common fractions? That's what we're going to do here, right? So I need to convert 0.25 into a common fraction, right? What does that mean? I have two decimals there, meaning it is 100, right? So this will be the same as 25 over 100. if you simplify this, it will be 1 over 4, right? So that's, I'm just showing you this because at times you're not going to get a straightforward decimal like this one, where you know 0.25 is just a quarter, right? At times you'll get a decimal that cannot just be converted from the get-go, and you will need to employ this method that I just showed you. So this will be the same as 1 over 4 to the exponent of 2 minus x equal to, this is 2 to the exponent of 5 divided by 2 to the exponent of x plus 3. And then I play around with my maths here. This will be the same as 1 over 2 squared to the exponent of 2 minus x. I'm not changing anything as yet, and then here I'm just going to apply the laws of exponents, right? I'm dividing and my bases are the same, so it will be 2, 5 minus x plus 3. And then on the left-hand side, you know that this is going to be the same as negative 2 there as the exponent, and then 2 minus x is equals to 2 to the exponent of 5 minus 3 will be 2 minus x, and then you can then simplify this from there, right? So this will be 2 to the exponent of minus 4 plus 2x equal to 2 to the exponent of 2 minus x. Now what do I do? Bases are the same. I have one power, equate the exponents. So that will be minus 4 plus 2x equal to 2 minus x. You play around with your maths. This becomes 3x equal to 2 plus the 4, which will give me 3x equal to 6. Therefore, my x will be equals to 2, right? You divide both sides by 3. And then you can quickly also check your answer here. If I substitute my 2 there, it's going to be 2 minus 2 here. And 2 minus 2 is 0, so 0.25 to the exponent of 0 will be 1. And then on the right-hand side, if you substitute 2 here, it's going to be 2 to the exponent of 2 plus 3, which is 2 to the exponent of 5. So also it will give you 1. And then you know that your answer is then correct. So remember to always just check your answer if you have some time. But if you do not, then just make sure that you follow the correct statements there and the correct steps. So mainly, bases must be the same. One power, equate the exponents, and then find your answer from there. Hi guys, welcome back from the ad break. So we are still looking at exponential equations that we are trying to look at. Now we're gonna mainly look at some exponential equations that involve rational exponents. But let me show you what I'm talking about. So the main keywords here will be the rational exponent, because you need to know exactly what is a rational exponent. Now, when solving exponential equations, right, and they include addition and subtraction of several terms, the main thing is to always factorize in order to solve the equation. And you know your types of factorization here will be the common factor, and it will be the trinomial way of factorizing. But before that, I just want to go back to the concept of a rational exponent quickly so that you understand what we are talking about, right? So remember, from just defining number systems when we started doing our maths at an early age and all of that, they called a rational number as a number that can be written in the form of A over B. Similarly with a rational exponent, it's the same thing. It's an exponent in the form of a fraction. That's it. It's nothing different or anything like that. The rational part of it still means a rational number, but it is a rational number that is an exponent at that time. So you really need to make sure that you do understand that. Now, when solving using the common factor, make sure that first your bases are the same. What do? You look at the exponents, right? And when you're looking at the exponents, the coefficients of the variable are the same in all the exponents. That's what a common factor means. So it means I have 3 to the exponent of x, right? Multiply by 2, maybe to the exponent of x, like that. So what this means is I am looking at the bases that are not necessarily the same, but my exponents are the same, right? But I can't take out a common factor here unless I then say plus 3 to the exponent of x. Then you can see that my bases here will therefore be equal. So that's really what I mean there. There will always be what we call a constant term that is present, meaning after taking out a common factor, there should definitely be a constant term. Now, when it's a quadratic trinomial, again, the goal basis must be the same. From there, you look at your exponents, right? What will happen with the exponents is the coefficient of the variable are not the same in all the exponents. What does that mean? It means that one exponent will be twice the other exponent, or it will be a negative of the other exponent. What do I mean? It will be maybe 2 to the exponent of 2x minus maybe 3 multiplied by 2 to the exponent of x, and then maybe also minus 4, like that. Because remember, it's a trinomial, so it's 3 terms, right? You can already see that my exponent here is 2 times that exponent there, right? 2x is twice x, and it's a trinomial. So that's the main thing that we need to look at. And why am I looking at this? I'm looking at this because the bases are the same of those exponents I am talking about, right? So that's what I mean when I say look at your exponents. And then always, you know, I'm going to have a constant term because it's a trinomial, and a trinomial always ends with a constant term. But now let's put this into the actual practicality as to what exactly do we mean. The question, as always, it will be solve for x, and then to solve for x, you will need to look at what is it that you are given, right? So firstly, I will write this in standard form. In standard form, this is the same as 2 to the exponent of x multiplied by 2 minus 2 to the exponent of x minus 12 equal to 0, right? And as you can see here, you will then try to see if I can factorize this. Firstly, if these exponents, one is twice the other, then I can factorize. But look at them. Are they twice one another? No, they are equal. Therefore, what method must I use here? I use the method of a common factor, right? So I will then use the method of a common factor. So immediately that is the case, I will just erase this because I just wanted to show you how you then need to look at this. So this will be equals to the 12 will remain where it is. Why is it remaining there? Because the exponents are not the same. Are the same, I mean. One is not twice the other. If it was, then it will be a quadratic trinomial. Now on the left hand side, this is squared there. I just forgot that 2. So if I take out a common factor, it will be 2 to the x into 2 squared minus 1. And this will be equals to 12, right? And then this will be 2 to the exponent of x into, in the brackets, I have 2 squared, that's 4, minus 1, that will be 3, and that's equals to 12. You divide both sides by 3. Let me use a different color just so that people can see the differences here. If you divide both sides by 3, I will have 2 to the exponent of x equals to 4. And then from here, you know, it will be 2 to the exponent of x equals to 2 squared. Bases are the same, 1 power, equate the exponents. So it's x is equals to 2. Then you can always just take that 2, substitute it back so that you can check your answer, right? So to do that, I will just write it on top, but I will work it out for you here. So if I write it there on top, 2 plus 2 will be 4. 2 to the exponent of 4, I know will be 16, minus. This one will be 2 squared, and 2 squared is 4. I minus that, and this will give me 12, which is the same as that answer there. So that will therefore mean that my answer is definitely correct. And then we look at this one here. This is going to, firstly, let's simplify everything. It's going to be 3 multiplied by 3 to the exponent of 2x minus 3 to the exponent of 2x times 3 to the exponent of minus 1 equals to 24. Why am I not changing the 24? Because you can see that I have this exponent and that exponent, and they are the same. So it means there's a common factor here. So it will be 3 to the exponent of 2x into 3 minus 3 to the exponent of minus 1 equal to 24. And then if you simplify the bracket there, it will be 1 over 3. And therefore, it's going to be 9 minus 1, which is 8. So this is going to be 3 to the exponent of 2x into 8 over 3. And it will be equals to 24, right? And then multiply both sides by 3 over 8 or divide by 8 over 3, however way you prefer to do it, right? So this will give me 3 to the exponent of 2x equals to, if I multiply the 24 by 3 over 8, the 8 there goes 3 times. If I multiply those two, they give me 9, right? So this will just be 9 there. But you can just use your calculator. You don't really need to do it using mental maths like I am. 3 to the exponent of 2x equals to 3 squared. Bases are the same, 1 power, equate the exponents. So it's 2x equals to 2, and then x equals to 1. And then you can always just test your answer whether it's correct or not. Now, let's look at this one now. With this one now, there's a different thing that is happening here, right? So let me quickly show you the first two that we did. My exponent was the same as the other exponent in terms of the variable. The exponent was the same as the other exponent. But now, if you look at this one, this will be 3 to the exponent of 2x minus 4 times 3 to the exponent of x times 3 plus 27 equal to 0. Already you can see that this is x and that is 2x. So one is twice the other. So as soon as one becomes twice the other, then we treat it as a quadratic trinomial, and then we try to simplify it from there. But firstly, before you do that, remember, just like any other algebraic equation that you will have, if I have a common factor throughout, I can divide by that common factor, right, which is a number. At that point, it will be the highest common factor, and then only factorize after. So we look at that even here. So you can see that I have this 3 there. Maybe I can try divide by it, but if I do that, this will make it 2x minus 1. So I will just make it 3 to the exponent of x all squared minus the 12 times 3 to the exponent of x plus the 27 equal to 0. And then you know, I said if you do not know what to do, you can say let 3 to the x equal to k. It means that if you let this to be equal to k, this will be k squared minus 12k plus 27. You can now factorize this, right? To factorize this, it will be 9 and 3. So this will be 3 to the exponent of x minus 9 into 3 to the exponent of x minus 3, right? Equal to 0. And therefore, this will be 3 to the exponent of x equals to 3 squared. Why 3 squared? Because 9 is the same as 3 squared. Or 3 to the exponent of x is equals to 3 to the exponent of 1, right? Then my final answer here will be x is equal to 2 or x is equal to 1. Then you can always go back, substitute, check whether your answer is correct or not. If it is not, then you leave it at that. So you then go back and recheck where you went wrong and all of that, because if it's not the same on either side, then there's something that you did not do right there. Guys, I know we've done a lot so far, but now I want you to just quickly take a walk around the house, try to drink some water, refresh a bit, look at your notes and try and make sense of what you are seeing, because after the break, we're then gonna do some more work. Hi guys, welcome back to the show. So we've been looking at a lot of things, guys. We looked at some exponential equations, right, that have to do with factorization and all of that. So now we're going to just close it off with some sets there and there, and we're also going to look at some other concepts that have to do with some exponential equations. So let's just jump right into it and see exactly what I'm talking about. Now, equations with rational exponents, as I said, remember the rational exponent will be in the form of m over n, right? That's a fraction rather of an exponent. Thus, an equation with rational exponents will then be given in the form of x to the exponent of m over n, all equal to a, right? Doesn't matter what a is. The most important thing there will be just having that exponent there as a rational exponent. Now, to solve these equations, the main thing that you need to make sure is you raise both sides of the equation to the reciprocal. Remember, we spoke about the reciprocal. The reciprocal will be whatever that was the numerator becomes the denominator, whatever that was the denominator becomes the numerator of whatever the fraction is. So in this instance, our fraction was m over n. So it means the reciprocal will be n over m, right? When you raise it, it's the same as you multiplying the exponents, right? Therefore, this and that will divide, that and that will divide. I will be left with just x is equals to a to the exponent of n over m, like that, right? So that's what I will then have there for you. Now, we have some special cases that have to do with rational exponents, right? Case one is where, where x to the exponent of m over n is equals to a, where the a value is a positive and the m value is an even number, right? A value will be this, so this is a positive, and the m value there will be the even number, right? This is a very special case, and there's going to be the next special case. What this means is the answer here is going to be plus or minus a to the exponent of n over m. Why? Because it will be more like you are square rooting on both sides, right? Or fourth rooting if it's 4. So let me just make an example of what I'm talking about here. So if I give you x to the exponent of 2 over, it doesn't matter, let me just leave it as n, is equals to 4, right? If I simplify this thing on the left-hand side, it is the same as me having x to the exponent of 1 over n raised to the exponent of 2 there, right? And is equals to 4, you see. So what does this mean? If I then square root both sides, this will give me a plus or minus on the right-hand side. It will give me a plus or minus because of that squared. That's really what I just mean here. Now, the opposite of this does not give us a solution. If m, right, is either, or the m or the n is an even number, it doesn't matter, but the a value is a negative, there is definitely no solution there. What do I mean? If I give you 2 to the exponent of minus 3 over 2 is equals to, right, negative x like this, right? So you can already see that there is no way that I will have negative x to be changed to have a base of 2 and a base of 2 that is positive in order to do anything there, right? But let me make it in terms of x. So if I give you x to the exponent of negative 3 over 2 is equals to minus 4. There's definitely no way that I will then deal with this in terms of getting a solution. Why? Because of that negative there. I can't change what is on the left hand side and make it to have a positive there. But let's just look at examples, exactly what do we mean. So remember, you raise this to the reciprocal of the rational exponent. So it's going to be x to the exponent of 3 over 5 times 5 over 3, which is equals to 2 to the exponent of 3. I will just change the 8 so that it's easier to simplify, raised to 5 over 3. And this will give me x is equals to, remember the m value is the one at the top, is not an even number, right? So it's not going to be plus or minus. So the 3 and the 3 will divide. I will be left with 2 to the exponent of 5, and then my x will be equals to 32, and that will be the answer there. And then if I have the exponent now as a negative, it doesn't really make a difference, especially if the value on the right hand side is a positive. So this will be x minus 5 over 2 times minus 2 over 5, which is equals to, I will also change 32 to 2 to the exponent of 5, and this will be raised to minus 2 over 5 rather. Minus 2 over 5. Minus 2 over 5, and this will be x is equals to the 5 and the 5. I will be left with the 2 to the exponent of minus 2, then x is equals to 1 over 4, and that will be my answer there. Now, a special case, right? This is the special case I was talking about. Immediately you see this, you know that this cannot be changed to have a negative, a positive rather, because it's a negative. So here you will just say no solution. And why is that the case? Remember my special case. When x to the exponent of m over n is equals to a, where a is a negative and m or n is even, it doesn't matter which one is even, there will not be a solution there if you are trying to solve that, right? So make sure you do understand that concept there. So here you're simply just going to say no solution. Also, even with this one, there will not be a solution here. Why? Because of this negative that I have here. But let's just try and see if we will be able to solve this. Maybe if we just try it, right? So that people can see what I'm talking about. Equals to, this is going to be negative. But now, I can't say this is negative 3 to the exponent of 3 like that, right? Oh, actually I can. Why? Because 3 to the exponent of 3 is 27, which will give me what I have there. And then I will need to multiply the whole thing, right? The whole thing by negative 2 over 3. But then how do you do that? Because there's a negative there, you see. So this will definitely be x equal to. But what I have here, I can't distribute the negative to that negative there. There is no way I'm going to do that. I also can't, this I can distribute to this exponent, but I can't distribute that negative there. So it will therefore be a concept of a no solution as well, right? You can just leave it as no solution. Now, the last example now, which involves the concept of rational exponents, will then be, what do? You change the radical to be in the form of an exponential form. So this will be the same as 9 to the exponent of x squared plus x, right? And then this will all be raised to the exponent of 1 over 3 like this. And this will be equals to 9 to the exponent of 2x. And then you can then simplify this, 9 to the exponent of 1 over 3 x squared plus 1 over 3x equal to 9 to the exponent of 2x. Why am I not changing these bases? Because already 81 gives me the base of 9. So you can already see that my bases are the same. I have 1 power, I equate my exponent. So it is 1 over 3 x squared plus 1 over 3 x equals to 2x. And then you can then start simplifying from there, right? You can just start by taking out x as a common factor or dividing everything by x, and then you solve it. So quickly, just to show you what I mean, this is going to be x into 1 over 3x plus 1 over 3 equal to 2x, and then I will have 1 over 3x plus 1 over 3 equals to 2, because I divide both sides by x, and then it will be 1 over 3x equal to 2 minus 1 over 3. And then from there, I know you can then press your calculator and simplify this. Now, so far, guys, what I want you to please go back and look at is the concept of your laws and definitions of the exponents. You need to make sure you make them rock solid, and then also go and look at solving exponential equations by making sure that the variable term and the constant have the same basis, and then you equate the exponents, because that's really the main thing that you need to do. Guys, I hope you enjoyed this lesson as much as I did. Exponents, I know, is a bit of a challenge for you guys, but I hope you've been following and you understood everything that you've done. If not, just go back to the notes that you made and revisit them, and also consult your textbooks and everything that can give you some knowledge in terms of understanding exponents better. From me, the Maths Doctor, remember, mathematics is food for the soul. Until next time.